Transformational Geometry Summary and Review. This video illustrates the solutions. This page shows at what times you can find the explanation of certain problems. Please go to the time listed for your problem and press pause as needed. Transformational Geometry, Summary, and Review. Number 1 asks you to reflect this triangle about the y-axis. So we first need to draw lines perpendicular to the y-axis from each of the pre-image points. So from F, I'll have to go in the opposite direction along this line. D will go in the opposite direction here, and E will go in the opposite direction along this line. So for point E, it's 1, 2, 3, 4, 5, 6 units, but in the opposite direction. 1, 2, 3, 4, 5, 6. So there is E prime. D will go 1 unit in the opposite direction this way. There's its mirror image. And F will go 1, 2, 3, 1, 2, 3, and there is F prime right there. So here is D prime, E prime, F prime right here in blue. If the measure angle F is 70 degrees, the measure of F prime would also be 70 degrees. The triangles are congruent. If the slope of segment DE is positive 6/7, D prime, E prime would have a slope of its opposite, negative 6/7. If the coordinates are E or 6, 4, what are the coordinates of E prime? Well, it's the same height, but in the opposite direction. So negative 6, 4. The area is 24 square centimeters. They both have the same area. They're congruent triangles. And generalizing the point, if the coordinates are x, y, then on the image triangle, it's going to be the opposite of x, y. Press pause as needed. Number 2 asks us to reflect the triangle about the x-axis. So again, I will go perpendicular to the x-axis this time and in the opposite direction for each of these points. And then from A, it'll be 2 units to the line of reflection, so A prime will be 2 units opposite directions. There's A prime. B prime will be 3 units in the opposite direction along this line, and C will be 1 unit from the line of reflection. So there's the image points. The triangle would look like this. And if A is 35, so is A prime. BC is 8, so is B prime, C prime. The slopes are opposites, same slope but in opposite directions. Perimeters are the same. Generalizing the points, it's going to be x, the opposite of y. The x coordinates are the same, but the y coordinates are opposites. And if a point is on the image going backward to the pre-image, it would still be the same x coordinate but the opposite of the y coordinate. Press pause as needed. Number 3 asks us to reflect this triangle about the line y equals 3. So I'll go ahead and graph y equals 3. It's a horizontal line through y equals 3. And now I'm going to have to go perpendicular from those points to that line, but go in the opposite direction. And so M prime would be 2 units away from this blue dashed line in the opposite direction. N prime would be 1 unit in the opposite direction from N. And O prime would be 1, 2, 3, 1, 2, 3. There's O prime. Drawing in the triangle that would look like this. And so the coordinates, you'll notice the coordinates have the same x coordinates, different y coordinates. So M and M prime, except they're no longer opposites because they're going about a line that's not on an axis. N, again, has the same x coordinates, different y coordinates, and O prime. Press pause as needed. Number 4, reflect this triangle about the line x equals -2. So x equals -2 is a vertical line, so it would look like this. And then I will be going in the opposite direction perpendicular to that. So Q prime would be along this line, P prime would be along this line, and R prime would be along this line. Q prime is 1 unit away from this line, but in the opposite direction. R prime is 1, 2, 3, 4, 5, 6, 7 units, but in the opposite direction. 1, 2, 3, 4, 5, 6, 7. And then P prime is 1 unit on the other side here. Connecting those, there's our image triangle. The coordinates of the vertices, again, they have the same y coordinates, but different x coordinates. Same y coordinates, different x coordinates. Same y's, different x's. Press pause as needed. Number 5 asks us to reflect this triangle about the line y equals 2x. First, we're going to have to graph the line y equals 2x, which goes through the origin and has a slope of +2 up 2 over 1. So I'll connect those with a line. There's a line y equals 2x. So now to reflect, I need to have lines perpendicular from each of the pre-image vertices, perpendicular to the green line. Since this has a slope of 2 over 1, the slope of perpendicular would be the opposite reciprocal, -1/2. So from S, I'm going to have to go down 1 and over 2, and down 1 and over 2, and that's going to be where the line hits. So I'm going to have to go do another, I'm going to have to do 2 more of those steps. Down 1, over 2, down 1, over 2, and that's going to be where S prime is. U prime, I'll go again, slope is +2, so I'm going to have to go down -1/2, and then go in the opposite direction, -1/2. And there's where U prime would be. And then T prime, I'm going to have to go down 1, maybe I'll just draw that, down 1, over 2, down 1, over 2, down 1, over 2. So I'm going to go 3 steps in the opposite direction. Down 1, over 2, down 1, over 2, and down 1, over 2. And there's where T prime would be. Press pause as needed. So now that I've got the lines perpendicular, I can go ahead and answer the questions. Notice there's not really a pattern here between x and y because it's going about the line y equals 2x. So this concludes the questions about reflections. This begins translations with number 6. We want to translate this triangle up 3 units and to the left 6 units. So from I up 1, 2, 3, and from here 1, 2, 3, 4, 5, 6, and that's where I prime would be. Similarly, we'll go up 3, left 6, up 3, left 6, and then this is what it would look like. G prime, H prime, I prime. Here's what the image would look like. Answering questions then, if GH is 9, G prime, H prime would be the same. They are congruent. If the perimeter of GHI is 36 centimeters, then the perimeter of its image should be the same. Again, they're congruent triangles. This is an isometry. If the slope of HI is 5/2. Notice these are parallel, so they have the same slope. And if the coordinates of h are 6, -2, then the coordinates of h prime should be 0, 1. And the reason for that is left 6 means subtract 6 from the x coordinate, and up 3 means add 3 to the y coordinate. The answer E also has you do go same thing, subtract 6 from the x, add 3 to the y. Press pause as needed. All right, similarly for F, G, and H, if point Z prime is on this and has coordinates -2, 2, now we're going the other direction. So here the coordinates of Z on the pre-image would be 4, -1. Here you would add 6 to the x and subtract 3 from the y. So if the coordinates, to generalize this, then what we're doing is it's x minus 6, y plus 3. The parallel segments, and list the slope. GH and G prime, H prime are parallel. Their slopes are 1/2, up 1 over 2. HI and HI prime are both 5/2. And GI and GI prime are both have a slope of 1. Press pause as needed. Number 7, we want to translate this triangle by vector PQ. So what we're going to do is draw in some of those vectors. So I have 3 of those vectors. So I'm going to go ahead and slide that. It looks like they all have the slope of +2/5. So from E, I'm going to go up 2 and over 5, and E prime would land right here. F will go up 2 and over 5, and F prime, that image will be right here. And D up 2 and over 5, and D prime will go right there. And it should look like this: D prime, E prime, F prime. Answering the questions then, the coordinates, just read them off of the grid. Now this one reverses it. If A prime were to be on the image and had coordinates 6, 1, what would the coordinates for the pre-image be? So instead of adding 5 to the x coordinate, we have to subtract 5. Instead of adding 2, we have to subtract 2 from the y coordinate. Which segments are parallel to the vector? Well, you can see that EE prime, DD prime, and FF prime are all parallel because we kind of made clones of them to get the translation. And what is the slope of each one of those? +2/5, up 2 over 5. Press pause as needed. 7D asks, name 3 other pairs of segments that are also parallel and state their slopes. Well, DE and D prime E prime, EF and E prime F prime, and DF and D prime F prime should be parallel. DE and D prime E prime have a slope of 5/2, -2/7, +1/3, just by reading off of the grid. Press pause as needed. Number 8, you're given some triangle DEF is translated to the left 7 units and up 5 units, and you're asked these questions about them. So if D has coordinates 5, 7 on the pre-image, what are the coordinates for D prime on the image? Well, since we're going to the left 7, that means this is going to go back 7, subtract 7 from the x, and up 5, add 5 to the y. So that should be -2, 12. E is also on the pre-image. We're going to have to subtract 7 and add 5, and we get -10, -2. Part C, though, is F prime is on the image. We're going to go backwards. So instead of subtracting 7, we're going to have to add 7 to the x and subtract 5 from the y. So that will make it 8, 1. Generalizing, if D is on the pre-image, what will be the coordinates for D prime? And so it's going to be x minus 7 going to the left, y plus 5 going up. Reversal, if P, Q are on the image, what's on the pre-image? Well, it would be the reverse. Add 7 to the x coordinate, subtract 5 from the y coordinate. This concludes the translations. This is Transformational Geometry Summary and Review on Rotations. Number 9A, we want to rotate triangle DEF about point R 90 degrees. We're going to call it triangle D prime, E prime, F prime. 90 degrees means perpendicular, so I'm going to go ahead and connect R and D on the inside concentric circle, and then make a 90-degree angle again on that inside concentric circle, and use that for my D prime. Similarly, I'm going to do the same with E, only this is on the second circle, so straight up to E and then make 90 degrees there, and that's where E prime will be. And then finally for F. So I'll go R to F on the outside circle, and then make a 90-degree angle over this way on that outside circle, and that's where F prime is going to be. And there's my first image triangle. Part B, rotate the same triangle about our 180 degrees. That would be pretty much a straight angle. So I'm going to start with D, go straight through R and make a straight angle right across there. And so that's where D prime would be, or D, I should say D double prime would be. Same thing with E to E double prime. Straight down, only this time into the second concentric circle. And then finally through F. F to R, and then across on the outside circle, the largest of the three. And there's D double prime, E double prime, F double prime. C is 270 about point R, so that'll either be a negative 90 or it'll be straight across 180 from the red one, which however you want to do it. I think I'm going to go straight across from the red one just because I think that's going to be the easiest way to do it. So we'll do this one in green. So I'll start off with D and go through R and straight across, and that's where D triple prime is going to be. Similarly, E prime across through R to the second circle and drag that over there to be E triple prime. And then F prime across through R to the outside circle. And that'll be F triple prime right there. And that's part C there. D, if you go 360, you're just going to end up back at the original. So the blue triangle is the same as the answer for part D. And since all these triangles are congruent, the corresponding angles will be equal. And so measure of angle D prime is going to be 35 degrees. Press pause as needed. All right, looking at the other questions here, if segment EF has a length of 4.5 inches, then E double prime, F double prime also does, because all four of those triangles are congruent to each other. Rotations does preserve side and angle measures. Part G, if the slope of the original side ED were to be -2, then rotating 90 degrees, it would be the opposite reciprocal because they're perpendicular to each other, so it would be +1/2. In H, if the slope of the original was 2/3 and we went 180 degrees to E double prime F double prime, they are going to be parallel, as you can see. So 2/3, the same slope. I, perimeters are all going to be equal. This is an isometry. And the coordinates for each of these, well, if we go 90 degrees, it's usually y, comma, opposite of x. 180, opposite of x, opposite of y. 270, opposite y, comma, x. And 360, xy. It's the same. Press pause as needed. For number 10, we're going to rotate triangle XYZ 90 degrees about the origin. We're going to need our concentric circles, so we'll start with those. So I've got my concentric circles through Y, X, and Z. They're pretty close together right here. It's okay. All right, so let's go with Y first. So I'll go from the origin to Y and draw in a radius there. And then I need a 90-degree angle in this direction in the counterclockwise direction to make a 90-degree angle to that first point. So there, Y prime would be right there. Next, let's go to X. So I'll start at the origin and go to X and then go 90 degrees counterclockwise with that and go to the outside circle, and that's where, whoops, that's where my X prime is going to be. And then finally for Z to make Z prime. So again, here to here, 90 degrees counterclockwise. On the inside circle, and that'll be where Z prime is going to be. And so there is our image rotating 90 degrees about the origin. We can actually be able to figure out these slopes by looking at the drawing and also knowing about opposite reciprocals. So XY looks like it goes up 1, 2, and over 1, 2, 3, 4, 5. So the slope seems to be 2/5 here, making this -5/2. Segment YZ has a slope of down 1 and over 7, so -1/7. Y prime Z prime then should be +7/1. And then XZ looks like it is down 3/2, -3/2, and this one is up 2 and over 3, up 2/3. So should they be parallel or perpendicular? And they are perpendicular because of the opposite reciprocals. Press pause as needed. Number 11, we're going to rotate triangle XYZ, 11B that is, 180 degrees about the origin. So I've got my concentric circles in here. I'm going to go ahead and draw the lines in. I'm going to do this a little quicker this time. So there are my images, 180 degrees across. I'll go ahead and make it into a triangle and get rid of the construction lines. And here's the triangle. It's X double prime, Y double prime, Z double prime, 180 degrees. So we need to calculate the slopes and find out if things are perpendicular or not. So if you look at XY and also XY here, X double prime and Y double prime and XY, they seem to be parallel, and they are. So the slope is going to be up 2 and over 1, 2, 3, 4, 5, so 2/5 and 2/5. So we'll go ahead and finish filling those in. As for the other slopes, YZ and Y double prime and Z double prime rather will be -1/7. Looks like I got those a little mixed up. I think you know where I'm going with this. And the other two corresponding sides have the slope of -3/2. And what that would do is make all of those segments parallel to each other. Please press pause as needed. And finally, the last two questions. Just go ahead and look at the answers here. Corresponding sides of rotated triangles are congruent, that is, they have the same length. Corresponding angles of rotated triangles are congruent, that is, they have the same measure. And if you rotate a triangle about a point through any angle degrees, the triangles are congruent. Therefore, rotation is a rigid motion, also called an isometry. It is a distance-preserving and an angle-preserving transformation. That concludes rotations. Transformational geometry summary and review. This one focuses on dilations. Number 14 asks you, and all of the questions apply to this one figure. We're dilating triangle XYZ about point A with a scale factor of 3. And we're not going to show every step, but hopefully enough. So first we need to draw the lines through A and X, A to Z, and A to Y, extend them out. Our points are going to be somewhere along there, the vertices. And then what I need to do is mark off this distance twice more to be 3 times. So I'm going to go ahead and this from here to here is A to X. Here's another A to X. Here's another A to X. So that's where X prime is going to be. This will be triple the distance right there. Similarly, this is from here to here, the same distance from here to here is here to here. I'm eyeballing it since I don't have a compass. And I'll let you do the same thing if you don't have a compass. And then similarly, A to Y again, A to Y again. So connecting those, this is our triangle, that's the image, and we can go ahead and erase the construction lines. Press pause as needed, or go back as needed. I did also do this with TI-Nspire software to do the construction. Looks a little crazy, but hopefully that makes some sense to you. So answering parts A through D. If angle X is 20, so is it's the measure of angle X prime, because the angles are the triangles are similar, corresponding angles are equal. It's the same shape, it's a different size. So when YZ is 8 centimeters, its image should be triple that, 24 centimeters. Reversing that, if X prime Z prime is 30, XZ should be a third of that, which is 10 inches. And if the perimeter of the pre-image is 60 centimeters, the perimeter of its image should be triple that, 180. Press pause as needed. Part E has 3 parts to it. So the ratio of the perimeters is 3 to 1 when you're going from the image to the pre-image is 3 to 1. The areas, however, you might remember, are the squares of that, 9 to 1. This is covers 9 times more surface space than this does. And the perimeter in the other direction should be the reciprocal of this, 1/3. Press pause as needed. Letters F through I. So if the area of the pre-image is 72, the area of the image should be 9 times that. So 9 times that would be 648 square inches. It says what is true about the segments XZ and X prime Z prime. They are parallel. If the slope of XY is negative 3/4, another segment should be its corresponding one, and that's segment X prime Y prime, which also has a slope of negative 3/4. And if the distance from A to X is 10 centimeters, the distance from A to X prime should be 30, triple that. And the distance from X to X prime should be the 20, this because it should be 10, 20 more makes 30. Press pause if needed. J to O asks us to calculate some ratios as fractions. So first of all, A prime to X prime, A to X prime, and A to X should be 3 to 1. but going from AY to AY prime should be 1/3. Notice how having this drawing helps visualize that. The ratio of the lengths xz to x prime z prime also should be 1/3, 1 to 3. The ratio is 1 to 3. While the areas, as we said before, is 1 to 9. When we go from here to here, it's 1 to 9. Larger to smaller, it will be 9 to 1. The measure of these angles should be 1 to 1 because the ratio of the measures, that is, should be 1 to 1 because they are equal. Similarly here, they should be equal. So the ratio is 1 to 1. Press pause as needed. So P and Q have some hypotheticals, if and so on. Let's go ahead and look at those. All right, part 1 of P says if x has coordinates 6, -12, then the coordinates of x prime should be triple that. Number 2 goes the reverse. If the coordinates on the image are 6, -12, we should take 1/3 to get those answers because we're going back the other direction. Similarly, we go in from smaller to larger, they should triple, and from larger to smaller, they should be 1/3. If point A were to coincide with point X, then what pairs of sides would overlap? XY and X prime Y prime would overlap, and X prime Z prime and XZ would overlap. The other pairs of sides, YZ and Y prime Z prime, should be parallel to each other. We've seen that when we did the investigations. This concludes dilations. Transformational geometry, summary review. Here we're going to identify or describe the transformation. That is, given the pre-image and image, tell me what's going on. So number 15, it says, in each of the following grids, a triangle is transformed. State what transformation was done. Also describe what was done. So let's look at part A. So pre-image is the green triangle. The image is the blue triangle. And so it looks like these are on the same concentric circles. Looks like we have a 90-degree angle here or a 270-degree angle here. So we could say we rotated this triangle 270 degrees about the origin, or we rotated the green triangle -90 degrees about the origin. And all of those words are important there. Press pause as needed. B, the brown triangle is the pre-image, the green one is the image. For this one, I drew in connecting segments, and I could see it looks like this slid down here. Okay, so a slide is a translation, and it translated triangle ABC down 6 units in each case. Part C, the pre-image is brown, the image is green, and I drew in connected the origin and YY prime, XX prime, ZZ prime, and I could see that the triangle got smaller, so it's a dilation of some sort. We dilated the brown triangle about the origin with a scale factor of 1/2. It's 1/2 of what it was before. Here we have D, and I wasn't sure what was going on there, so I connected the corresponding vertices, and I'm trying to look at where the line would be that would be the midpoints of those and be perpendicular, and it turns out that would be the line y = x. So these are reflections about the line y = x. Reflect triangle BCD about the line y = x. Here we have 2 triangles here. The pre-image is red. The image is this navy color. Again, looks like I had to go over and down. In each case, the same amount. So that would be a translation. We translated triangle STU 10 units to the right, down 4 units. Looking at F, again, I connected corresponding vertices and saw that the midpoints for these green segments would be along the x-axis. So I'm going to say it's a reflection about the x-axis. Reflect the blue triangle about the x-axis to get the brown triangle. Here, again, I drew in concentric circles. I connected P and P prime and saw it made a 180-degree angle. So this is a rotation, rotating triangle PQR 180 degrees about the origin. You could have also said negative 180 degrees about the origin. H. Did I do here? I think I connected the origin with each of the corresponding vertices, and because the triangles were not the same size, so it's not a isometry or a rigid motion, so it looks like it's got to be a dilation of some sort, and it looks like we're dilating triangle CDE about the origin twice as big with a scale factor of 2. And this concludes the video.